find even faster on the calculator. There's something called the square of a number, which most of you know is taking a number and multiplying it by itself. For instance, 5 squared would be 25. 6 squared would be 36. 73 squared would be something bigger, right? Now, most of your calculators have shortcuts for squaring numbers. Like if I want to square 5, I can press 5, then times, and then equals, and that will give me the square. If you know the shortcut for squaring, go ahead and use it. What I'm going to try and do now is to square in my head 4 two-digit numbers faster than they can do on their calculators, even using the shortcut method. I'll ask these 4 people, how about here in the first row, 1, 2, 3, 4, each yell out a two-digit number, and if you would square the first, the second, the third, and the fourth one, I will try and race you to the answer. So, quickly, a two-digit number, please. 43 squared, okay, next. 23 squared, next. 25, and one more. 96. Would you call out your answers, please? Well, starting with you, what do you have? 1,849.
12,167.
I think you did 23 cubed. Try 23 squared. I'll do 23 times 23, okay? What do you have? 625. What do you have? 9,216. And finally?
529.
Give them a round of applause. Let me try to take this one step further. I'm going to try to square some 3-digit numbers this time. I won't even write these down. I'll just call them out as they're called out to me. Anyone I point to, call out a 3-digit number. Anyone on our panel, verify the answer. If I get the answer right, give me a thumbs up. If I make a mistake, let me know and I'll try and fix it. A 3-digit number, go ahead. 658 squared, is that 432,964? Yes, okay, thumbs up. How about another 3-digit number, sir?
537.
537 is 288,369. 288,369, yes, good. How about another 3-digit number?
427.
427 is 182,329. 182,329. Yes, right, thumbs up, good. Another 3-digit number. 323 is 104,329. 104,329. Yes, good. How about another 3-digit number? Go ahead. 325 is 105,625. 105,625. Why don't you give us the last 3-digit number?
497.
497 is 247,009. Thank you very much. We're still getting warmed up here. Let me try to take this one step further. I'm going to try to square a 4-digit number this time. Now, I'm not going to beat you to the answer on this one, but I will try to get the answer right. To make this a little bit more random, how about I take 4 people, how about over here in the yellow shirts, 1, 2, 3, 4, just stay where you are, just each call out a single digit between 0 and 9. That will be the 4-digit number that I've squared. 6, 9, 1, 9. 6, 9, 1, 9. This will take me a little bit of time, so bear with me. 47 million. 842,561. No? Okay, all right, let's try again. 47 million. So far, so good? All right, a good estimate. I should stop there, but let's see. Gosh, 842. No. Try one more time. I must be making the same mistake each time. Try one more time. All right, 47 million. Oh, okay, I got it. 872,561. Good. Thank you very much. Now, I would attempt to square a 5-digit number, and I can, Unfortunately, some calculators cannot. Although I know some of yours do. You turn it on the side like that, but I'll talk to you later. In the meanwhile, let me conclude the first part of my show by trying something even trickier. Let's take the largest number on the board here, 9,216. Would you each enter 9216 on the calculator? And instead of squaring it this time, I want you to take that number and multiply it by any three-digit number that you like. But don't tell me what you're multiplying by, just multiply it by any random three-digit number. So you should have as an answer either a six-digit or probably a seven-digit number. How many digits are in your answer there? 6 or 7? You have 7, and you have as well 7 digits? How many digits are in your answer there? 6 or 7? You think you're doing it wrong. Take 9216 times a three-digit number, whatever three-digit number you like. Do you have a seven-digit answer? Yes? 7 digits? And 7 as well. Is there any possible way that I could know what seven-digit numbers they have? Say no. Yeah. Good. Then I shall attempt the impossible, or at least for those skeptics out there, the improbable. What I'd like each of you to do is to call out for me any 6 of your 7 digits, any 6 of them, in any order you like. One digit at a time, I shall try and determine the digit you've left out. So call out any 6 of your digits, say them slowly so I can repeat them for the audience. I will try and determine the missing digit. Go ahead. 2, 3, 1, 2, 6, 6. Did you leave out the number 7? Good. That's 1. You have a 7-digit number. Call any 6 of yours loud and clear. 4, 6, 8, 0, 7, 0. Did you leave out the number 2? Yes! That's 2. You've got a 7-digit number. Any 6 of yours in any order. 6, 0, 7, 2, 6, 4. Did you leave out the number 2? 2? Okay, good. The odds of me getting all 4 of these right by pure guessing would be 1 in 10,000. That's 10 to the 4th power. Okay, any 6 of yours, really scramble them up this time. 8, 0, 4, 7, 9. I'm missing one more. You said 8, 0, 4, 7, 9. You have the 7-digit number, right? I've heard 5 digits. 8, 0, 4, 7, 9, 2. Did you leave out the number 6? Good. And let's give all 4 of these people a nice round of applause. Thank you very much. Fantastic. For my next number, thank you, I'd like to produce something that we mathematicians refer to as magic squares. Now, for those of you unfamiliar with magic squares, they're kind of like Sudoku on steroids, and you'll see what I mean by that in a minute. Now, I've done such an extensive study on magic squares that I'd like to create one for all of you right before your very eyes. But for this, I'll need another assistant, someone here I do not know. And how about the young lady on the aisle there? What's your name? Come on up here and give her a nice round of applause. While she's making her way up, I learned an interesting fact the other day that I'd love to try out on this audience. Would you join us right here for a minute? I learned that, we think of numbers as being random. Like if you think of the number that's the house number that you live in, that's a pretty random number, right? About a 50% chance that it's an even number, about a 50% chance that it's an odd number. But check this out. If you look at the very first digit of your address, it is way, way more likely to be a low number than a high number. Let me try and test this with the audience. How many people here have an address that begins with 9? Raise your hand. Okay, I see a few hands up. How many have an address that begins with 1? Raise your hand. Isn't that interesting? Way more with a 1 than a 2, than a 3, than a 4, down to 9. Anyway, what's your name again? Liana, let's give Liana a nice round of applause. Make sure I can spell that out. Liana, let me ask you another question, and if it's too personal, I can change the question. Liana, are you willing to share with us your birthday, including the year? Good. Liana, what is your birthday? Well, you can say the month and the date and then the year. No, November 29th. And what year? 2004. Great. Now, Liana, if we were to add the numbers in your birthday together, we see 11 plus 29 is 40, plus 20 is 60, plus 4 is 64. So 64 becomes your magic number. What I'm going to try and do now, Liana, is to fill out this box in such a way as to get your magic number appearing here as much as I possibly can. This will take me, give me 1 second here. This will take me, oh, okay, wait a minute, try something. I see something special I can do if I make that attempt. Here we go. All right, so I'm going to fill out this box in such a way as to get your magic number appearing here as much as I possibly can. This will take me a couple of seconds, so bear with me here. I think that works. Liana, would you choose for us any row? Row number 2, 3, or 4, which would you like? 2. All right, class, together. 19 plus 5 is 24. Plus 10 is 34. Plus 30 is 64. The others are 11, 40, 60, 64, 5, 26, 54, 64, 29, 38, 44, 64. Would you choose a column, Liana? 1, 2, 3, or 4? 3. All right, class. 20 plus 10 is 30. Plus 28 is 58. Plus 6 is 64. The others are 11, 30, 35, 64, 29, 34, 45, 64, 4, 34, 44, 64. How about that? Liana, I'm not through with you. I decided since this was your magic square, based on your birthday, at no extra charge, I would give you these diagonals as well. Check it out here. 29 plus 21 is 50, plus 10 is 60, plus 4 is 64, 11, 16, 44, 64. But I didn't stop there either. I decided since this was for Liana, wouldn't it be great if we could get these 4 in the center to add up as well? Check it out here. 5 plus 10 is 15, plus 28 is 43, plus 21 is 64. But did I stop there? No, Liana, you may have noticed I put a little extra attention in that corner. I did that so I could get these 4 squares. 11 plus 29 is 40, plus 5 is 45, plus 19 is 64 to add up. And I figured, heck, as long as we got that group of 4, let's have a party. We may as well get this group of 4, 20, 24, 34, 64, 5, 26, 35, 64, 20, 38, 64. But did I stop there? No, I said Liana wouldn't be happy unless we got this group of 4, 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 this group of 4. I have to apologize, I was not able to get this group of 4 nor that group of 4 to add up, but I had to do it that way if I was going to get these 4 in the corners. I knew that would be important to you. 11, 15, 35, 64. But wait, here's the cool part. Liana, not only do those 4 numbers in the corners add to 64, if you look at them closely, you'll see we have 11, 29, 2004. I was able to give you your birthday twice. I thought you'd like that. So please keep this as a souvenir from me. Let's all give Liana a nice round of applause. Thank you. Hey, speaking of birthdays, by any chance, does anyone here happen to know the day of the week that they were born on? If you think you know your actual birthday, raise your hand. I started with you. What year, if I may? Oh, Monday. No, I needed the year first. Okay, I'll tell you what, it's much harder to go backwards. Let me get back to you on that. Somebody else, give me the, what year was it, first of all? 2003, in what month? December what? The 11, was that a Thursday? Yes, good. Somebody else in the red shirt there, what year? You're looking back, maybe not good. Oh, what year? March? March what? 2005, and March what? 18? 8. Was that a Tuesday? Yes, good. Somebody else in the white shirt there. What year? 2004, and the month? February what? 9. Was that a Monday? Yes. All right, how about yours? You came running down. What year? No, I was asking her. Or maybe that wasn't. What year are you born? 2008. Okay, let me think about that one for a second. Okay, and what month? July what? 2. Is that a Wednesday? Yes. Any parents or staff here that know, that are willing to share? Okay, gentleman in the black shirt and hat. What year? Yell it out.
86.
86. And what month?
October.
October what?
2.
2. Was that a Thursday?
Yeah.
Yeah. How about you, sir? What year? Yell it out. 79. And what month? June 15th. Was that a Friday? Oh, now you know. Now you know what? I actually, he shrugged his shoulders. I don't know. Now we know. But I actually come prepared for that. There are apps for everything these days. And let's see, Roosevelt, can I get you to come up close to the stage? All you have to do is type in the year. The rest is pretty clear. So you said it was 1979. So type in 1979. And what did you say? It was June. Press the June button. Look at the calendar. And June what? 15, which I believe is a Friday. It is a Friday. I'll tell you what, Roosevelt, as long as you have the app with you, let's try something even more challenging. The app will go as far into the past as 1600 and as far into the future as the year 3000. So choose any year you like between 1600 and 3000. Not too close to this year, so it's more of a challenge. 1785, okay, and let me think about that for a second. And, okay, and what month would you like?
April.
April what?
11.
11. Was that a Monday?
Yes.
Yes, and it was cloudy. That's another app. Thank you very much. In fact, anyone else who wants to find out their day of the weeks, not now, but see me after the show. I'll be here at my table with my DVDs, and I'll be more than happy to tell you. Now, folks, if I were performing for a different sort of audience, like say at the Magic Castle in Hollywood, has anybody here been to the Magic Castle in Hollywood? A bunch of you. It's a fantastic place. I perform there a few times a year. And so if I were performing at a place like that, I would follow this up with other feats of magic and mind. But for an audience such as this one, I actually prefer to break the magician's rule and explain to you most of what you see me do up here and more. In fact, I'd like to conduct the rest of this program, the next 30 minutes or so, very informally. So feel free at any time to interrupt me with questions, even if it has nothing to do with what I'm talking about. It's more interesting that way. But inevitably, I've got hours and hours of stuff that I can tell you, but only maybe 20, 30 minutes remaining to be up here. So I'd like to answer your questions right now. What is it that you'd like to know? Who would like the first question? Yes, sir. What's your question? Oh, I'm sorry. What's your question, Matt? How did I figure out the day you were born, the birthdays? Okay, I'll show you that one. Now it's a little tricky, but you can do it, because you guys are some of the smartest math kids around, so you're going to be able to understand this. It's probably the most practical thing that I do, because it's not every day that someone will ask you to square a 3-digit number, but it is every day that someone will ask you a date. mention a date to you, and it's really handy to be able to quickly figure out its day of the week. Let's see, I think for this one I might actually need two easels here, so I'll bring this one along as well. Okay, so let's see. So let me first show you how to figure out the day of the week this year, for the year 2015. And then I'll show you how to do it for next year, and the year after that, and then the rest of your life. And then if you're still interested, we can go back into the past and do birthdays. Now, 2015, every year gets a code number, and the code number for 2015 happens to be 4. And just take my word for that for now. Next, we need a code for every day of the week. And so if I write the days of the week, Monday through Sunday, the codes are 1, 2, 3, 4, 5, 6, and Sunday is 7, 4, 0. And that's easy to remember because Monday is one day. Tuesday is literally Tuesday, right. Wednesday with the W looks like a 3 on your fingers. Thursday is 4's day, Friday is 5 day, Saturday is 6er day, Sunday is 7 day, or Sunday is none day, or if you're Catholic, Sunday is none day. That's nice. Next, we need a code for every month of the year, and this is the tricky part, I'm afraid. It doesn't go 1 through 12 like we wanted to. The codes go 622, 503, 514, 624, and to make it even worse, on a leap year, the codes for January and February are one smaller. They're 5 and 1. And there are even tricks, mnemonics for memorizing this code. For example, January is winter, and winter has 6 letters. February is month number 2. That's the only one that works out. March 2, the beat of the drum. April, fools. April and fools both have 5 letters in their name. May is a 0. If you have a sandwich, you might want to hold the May-O, because it's healthier. A June, bug has 3 letters. In July, if you look at the sky, you might see a lot of fireworks in the sky. That's my best for that one. August begins with A, which is the first letter. September is fall. September has fall has 4 letters. And October, you might think of tricks or treats, which have 6 letters, or tricks rhymes with 6. November, you might have 2 pieces of turkey, spelled turkey with a 2, you'll remember it that way. And then December is the last month, last has 4 letters. Once you have those codes memorized, it's very easy now to figure out the days of the week. Now, the person who asked me for to do this, give us your birthday and we'll figure out what day of the week it will be this year. December 22nd of this year. Let's figure it out. Now, December is the last month, and so December had a month code of 4. For the 22nd, we add 22, just from that number. And for 2015, we always add 4, because I said so. Add those 3 numbers together, 4 plus 22 plus 4, we get 30. Now, if you wanted to, you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 until you reach 30. But you don't have to do it that way, because every 7 days, the week repeats. So you could subtract any multiple of 7. 7, 14, 21, 28, 35, and that won't change the day of the week. What's the biggest multiple of 7 that I can subtract from 30? 28. 30 minus 28 is 2, and so your birthday this year will be on a Tuesday. Exactly. All right? Let's just do one more example to make sure we all understand it. Okay, how about you, sir? What's your birthday? Yep, you in the checkered shirt, that's you. August what? You know it, I don't know it, but I'll trust you. August 23rd. for this year, 2015. Okay, so August begins with A, which is 1. For the 23rd, we add 23. For 2015, we still add 4. Add those together, we get 28. What should we subtract from 28? What's the biggest multiple of 7? 28 again. That gives us 0. And none day is Sunday, so your birthday will be on a Sunday. Got it? So now you know how to figure out the day of the week for any date this year. Well, what about next year? Well, what usually happens to your birthday as you go from one year to the next? What usually happens? It goes up a day, right? Why is that? Well, because usually there are 365 days between your birthday. And 364 happens to be a multiple of 7. 7 times 52 is 364. So if every year had 364 days, then your birthday would be on the same day each year. That would be boring, and that's why they don't do it that way. And something about the Earth and the Sun, right? But with 300